Geometry. So today is 9.5 day 2. Hopefully you've had a chance to practice a little bit. Our do now up here. For A, you should have cosine, and for B, you should have sine. All right, when you set them up, you get 20 times cosine of 53, and that gets you 20 times cosine 53 degrees is 12.03. So 12.0 in this case. And then for this one, we get 16 divided by sine of 68, which is 17.3. It says to round to the nearest tenth, so it's just one decimal place. So today, just to recap, we've talked about sine, we've talked about cosine, we've talked about tangent. Today, we're going to look at some more real-world concepts, okay? So like if I'm actually a surveyor on a road, how do I measure things? Like what do I do? So we have two things we're going to talk about. First one is angle of elevation. All right, angle of elevation is when you're looking up at something, right? Your head is elevated, so you're looking up at something, an object typically. The angle of elevation is formed by the observer's eye line of sight. That's this one right here, the line of sight, and where they are looking. All right, because that's your looking line, basically. So this right here is the angle of elevation. So you are the observer, you are looking, that's how that works. So the angle of depression, all right, the angle of depression is the next one we want to talk about. So it's when you are looking down at something. So you're on top of a building or on top of the Grand Canyon and you're looking down at something. This is formed by the line of sight with where you are looking. All right, so this is the angle of depression. Now here is something super cool. Let's say you've got Romeo and Juliet, right? There's one standing on the balcony, Juliet is, Romeo's down here. She is looking down. She has an angle of depression. All right, this is an angle of depression. Romeo is looking up, right? Looking up at Juliet. So this is an angle of elevation. Here's what's really cool. Because their lines of sight are parallel lines, right? They both look straight ahead, so even if one's taller than the other, their lines are parallel. Because they're parallel, that means that these angles are congruent because they're alternate interior angles. So the angle of depression, the angle of elevation, those are always going to be congruent. So it's really, really powerful, okay? They are congruent. If you can highlight that one, do it. This is really, really, really awesome. So how can we use that? Well, and this is a lot of word problems, I know, but that's just where we are with angles of elevation and depression. So draw a picture. I'm just going to say it over and over and over again today. Draw a picture, draw a picture, draw a picture. So we have a mascot. He's standing on the ground, right? So here is our little mascot right here. He is looking up. Well, here is his line of sight. So here's where he is looking. He's looking up at 36 degrees at a sports fan in the stands. So here's our little fan. So he's looking up at the fan. Yes, it's a terrible picture. It's fine. Okay? Don't judge me on my art. The fan is 25 feet above the field. So this is 25 feet. What is the distance from the fan to the mascot? So we want to know this one. So we can kind of see our little triangle right there, right? This is our triangle. This is 36 degrees, this is 25 feet, and we're looking for this. So we have to have a right angle here, right? Because that's how people sit. They sit at a vertical angle, and we're talking about like straight down, right? So that's just how it works. So that's our vertical. That means this is a 90-degree angle. So our hypotenuse is over here. This is our hypotenuse, which means the 25 feet is opposite that angle, and we are looking for the adjacent. So which of those three do we need? Sine, cosine, or tangent? Well, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Which of these do we need? We want the tangent, right? We have the opposite, we're looking for the adjacent. We need tangent. So we were able to plug in 36 degrees for tangent. We've got 25 over x. We can multiply both sides by x. Then we have to divide by tangent of 36. So that gets us 110.1 feet. All right, 0.1 feet. I rounded to 1/10, just like it's on the front side. We can do something similar with this one. So we have a lifeguard sitting on a platform looking down, okay, angle of depression down at a swimmer. If the swimmer is 50 feet away from the base of the platform, then the lifeguard's angle of depression to the swimmer is 18 degrees. So here we have our line of sight and where we are looking. That's 18 degrees. There's our swimmer, right? Here's our little platform guy. This says how high is the lifeguard in the platform. So we want this right here. Well, this angle is for depression, but the triangle we're looking at is actually right here, right? That's the triangle we want. This 18 doesn't help us, but we know that if the lifeguard has to look down 18 degrees, then the swimmer has to look up 18 degrees. So we can use that. That means this angle down here is also 18 degrees. So he has to look up 18. So our little triangle here, we know that this is 50 feet, and we are looking for our x. So we have opposite over adjacent, so that'd be tangent. Our opposite is x, our adjacent is 50. So you should get 16.2 feet. That's a really tall lifeguard tower, 16.2 feet. Or maybe it's not, I don't know how lifeguard, but I think it's tall. So there are 4 more problems on this page, okay? Draw a picture, try them out. I'm gonna pause here so you have an opportunity to just look at them, try it out. All right, our next one, number 3. We've got a pilot in a helicopter. He's 80 feet in the air. He spots a landing pad below. The angle of depression is 73 degrees. What's the horizontal distance between the pilot and the landing pad? So this is our x, right? Is the horizontal distance. We've got 80 feet up. You could draw your picture slightly differently. So you could draw this triangle down here, but in the end, you're still using tangent, and you should get 24.5 feet. For the soccer ball one, we've got a 34-degree angle from the soccer ball to the top of the goal. The soccer ball is 28 feet away. We want to know how high the goal is. You should have gotten 18.9 feet for your x. All right, that was a tangent. All right, the next one, we have Addie's mom is standing at the bottom of the slide at the playground waiting for Addie to slide down. Ooh, you cannot see those. Sorry, guys. I'll leave them there. That way you can see them. So waiting for Addie to slide down. If the angle of elevation is 46 degrees and the slide has a vertical height of 9 feet, what is the length of the slide? So we're looking for x. Well, that would be opposite over hypotenuse, right? So that's a sine. For this one, we've got building A is 480 feet tall and building B is 654 feet tall. If the angle of depression from the top of the building of A is 42 degrees, how far apart are the buildings? So the angle of depression is this guy right here. So this would be 42 degrees. So we want the opposite over the adjacent. So we need a pencil. There we go. Because I did this backwards. And I'm catching it now, which is, not the end of the world. So that guy's the 42 degrees. I thought it's the elevation, my bad. So we want x over 174 because it's opposite over adjacent. So we have to multiply by 174. So that means x is equal to 174 times tangent of 42 degrees. So it's 156.7 feet. All right, there you go. 19 sounded really weird. All right, if you have any questions, feel free to email me.